Good evening. Today I'm going to discuss the research title, Statement of the Problem, and Hypothesis. To begin with, let's define what is hypothesis. A hypothesis is an assumption or a generalization about a population parameter. The generalization will be tested, and this can be true or false. This is also a tentative generalization about the outcome of the research being investigated. This can be proved or disproved. A hypothesis testing refers to the formal procedures used by the statisticians or any researchers to accept or reject statistical estimation. A research hypothesis is a statement created by the researchers when they speculate upon the outcome of a research or experiment. It is a tentative statement that proposes a possible explanation to some phenomenon or event. A useful hypothesis is a testable statement which may include prediction. It is a statement or declaration of the expected outcomes of a research study. It is based on a logical rationale and has empirical possibilities for testing. Now let's proceed to statistical hypothesis. The main objective of a statistical hypothesis is to examine and evaluate the outcome or an assumption of whether a statistical hypothesis is true or false, or it could be rejected or accepted. Since examining the output or the outcome in general population, it is really impractical to review the total population. Thus, the next recourse was to examine the sample from the population. If there is mismatch in the sample data with a statistical hypothesis, then we have no strong evidence to accept the null hypothesis. Now there are four elements of a hypothesis. The first one is the variables. The variables being mentioned here is the dependent and independent variable. Okay? So the dependent and independent variables. The second one is the relationship or differences of the variables. This means that the relationship and differences of a dependent and independent variables. Okay, so what is independent variable? An independent variable is the stimulus variable which is chosen by the researcher to examine its relationship to an observed phenomenon. A dependent variable is the response variable which is observed and measured to determine the effect of the independent variable. The third is the direction of the changes. And the last one is the subject under the study. And then let's proceed with the characteristics of a hypothesis. Okay. The characteristics of a hypothesis should be testable. It should be logical. It should be directly related or very synonymous with the statement of the problem. It should state relationship or differences between the variables. and it is stated in a null form and will be in the form of a statement where it can be accepted or rejected. Now, there are two formations of a hypothesis. The first one is the directional hypothesis, and the second one is the non-directional hypothesis. A directional hypothesis predicts an outcome in a particular direction, whereas the non-directional hypothesis simply states that there will be difference between the groups of variables. There can be two hypotheses: research hypothesis and null hypothesis. The null hypothesis is formed for the statistical purpose of negating. If the research hypothesis states that there is a positive correlation between smoking and cancer, the null hypothesis states should be there is no relationship between smoking and cancer. The null hypothesis states that there is no relationship between smoking and cancer. In this case, it is easy to negate a statement of the problem than trying to establish. So again, a directional hypothesis predicts the outcome in a particular direction, whereas the non-directional hypothesis simply states that there will be difference between the two groups of variables. Now there are two types of a hypothesis: the null hypothesis and the alternative hypothesis. The null hypothesis, which is denoted by H sub O, is usually the hypothesis that sample observations results purely from chance. A null hypothesis stipulates that there is no difference between two conditions: outcomes, situations, groups, or prevalence of a phenomenon. It is always stated in a negative form. Again, the null hypothesis stipulates that there is no difference between two conditions: outcomes, situations, groups, or prevalence of a phenomenon. It is always stated in a negative form. The alternative hypothesis, denoted by H sub 1 or H sub A, is the hypothesis that sample observations are influenced by some non-random cause. This is the affirmation of the existence of an observed phenomenon, and it is always stated in a positive form. Okay, an alternative hypothesis is the affirmation of the existence of an observed phenomenon, and it is always stated in a positive form. Therefore, the null hypothesis and the alternative hypothesis are identical. However, null hypothesis is stated negatively, while the alternative hypothesis was stated in a positive way. For example, suppose we wanted to determine whether a coin was fair and balanced. A null hypothesis might be that half the flips would result in head and half would result in tail. The alternative hypothesis might be that the number of head and tail would be very different. Symbolically, this hypothesis can be expressed as H sub 0 is equal to P is equal to 0.5, meaning to say the chance that the result will be head or tail is 1/2 or 0.5. The alternative hypothesis says that it cannot be the same. It can be head or tail only. Suppose, okay, the second example, suppose that we flip the coin 50 times, resulting in 40 heads and 10 tails. Given these results, we would incline to reject the null hypothesis. We would conclude, based on the evidence, that the coin was probably not fair and balanced. Okay, let's proceed with the testing the hypothesis. Statisticians or researchers follow a formal process to determine whether to reject a null hypothesis based on a sample data. This process, called hypothesis testing, consists of the main steps: state the null hypothesis and alternative hypothesis, or simply state the hypothesis. This involves stating the null and alternative hypothesis. The hypotheses are stated in such a way that they are mutually exclusive. That is, if one is true, the other must be false. The second one, formulate an analysis plan. The analysis plan describes how to use sample data to evaluate the null hypothesis. The evaluation often focuses around a single test statistic. The third steps or process is to analyze sample data. It is to find the value of the test statistic, such as the mean score, the proportion, the t-score, the z-score, etc. This described in the analysis plan. And the last process is to interpret the results. This is to apply the decision rule described in the analysis plan. If the value of the test statistic is unlikely based on the null hypothesis, then reject the null hypothesis. The decision errors or the type of error. Okay. When the null hypothesis is rejected, the observed difference between groups are deemed improbable by chance alone. For example, if drug A is compared to placebo for its effects on depression and the null hypothesis is rejected, the investigator concludes that the observed differences most likely are not explainable simply by sampling error. The keyword in these statements is probable. When offering this conclusion, the investigator has the odds on his or her side. However, what are the chances of the statement being incorrect? In statistical inference, there is no way to say with certainty that rejection or retention of the null hypothesis was correct. Now there are two types of error, the type 1 and type 2 error. A type 1 error occurs when the researcher rejects the null hypothesis when it is true. So the type 1 error, rejection of the null hypothesis when it is true. The probability of committing a type 1 error is called the significance level. This probability is also called alpha, and it is denoted as letter A or something like this. Okay? A type 1 error occurs when the null hypothesis is rejected but should have been retained, such as when a researcher decides that the two means are different. He or she might conclude that the treatment works or those groups are not sampled from the same population, whereas in reality, the observed differences are attributable only to sampling error. In a conservative scientific setting, type 1 error should be made rarely. There is a great disadvantage to allocating treatments that really do not work. The probability of a type 1 error is denoted with this Greek letter. Because of the desire to avoid type 1 error, Statistical models have been created so that the investigation has control over the probability of a type 1 error. The second error is the type 2 error. A type 2 error occurs when the researcher fails to reject a null hypothesis that is false. Okay. The type 2 error is the acceptance of the null hypothesis when it is false. The probability of committing a type 2 error is called beta, and it is often denoted by this symbol. The probability of not committing a type 2 error is called power. The motivation to avoid a type 1 error might increase the probability of making the second type of error. In this case, the null hypothesis is retained when it is actually wrong. For example, an investigator may reach the conclusion that the treatment does not work when actually it is efficacious. The probability of type 2 error is symbolized by the Greek letter. Here, the decision is not to reject the null hypothesis when, in actuality, the null hypothesis was false. This is the type 2 error with the probability of beta. The first error, or the type 1 error, is that the rejection of the null hypothesis when it is true, while the type 2 error is the acceptance of the null hypothesis when it is false. Now the decision rules. The analysis plan includes decision rules for rejecting the null hypothesis. In practice, the statisticians describe these decision rules in two ways: with reference to a p-value or with reference to a region of acceptance. A p-value, the strength of evidence in support of a null hypothesis, is measured by the p-value. Suppose that the test statistic is equal to S. The p-value is the probability of observing a test statistic as extreme as S, assuming that the null hypothesis is true. If the probability value is less than the significant level, then we reject the null hypothesis. For example, we are using 0.05. So if the probability value or p-value is less than 0.05, then we need to reject the null hypothesis and conclude that there is a significant relationship or a difference. A p-value is sometimes referred to as the rejection or the acceptance of a hypothesis. Sometimes we are using or indicating that the p-value should be 0.5 or 0.1. The next one that guides in decision rule is the region of acceptance. The region of acceptance is a range of values. If the test statistic falls within the region of acceptance, the null hypothesis is not rejected. The region of acceptance is defined so that the chance of making a type 1 error is equal to the significance level. The set of values, the set of values outside the region of acceptance is called the region of rejection. If the test statistic falls within the region of rejection, the null hypothesis is rejected in such a way. We can say that the hypothesis has been rejected at the alpha level of significance. These approaches are equivalent. Some statistics texts use p-value approach. Others use the region of acceptance approach. Okay, in subsequent lesson, this tutorial will present the examples that illustrate each approach. Okay, let's proceed to testing the hypothesis. This lesson describes a general procedure that can be used to test statistical hypotheses. How to conduct a statistical hypothesis test. All hypotheses are conducted the same way. The researcher states a hypothesis to be tested, formulates an analysis plan, analyzes sample data according to the plan, and accepts or rejects the null hypothesis based on the results of the analysis. State the hypothesis. Every hypothesis test requires the analyst to state a null hypothesis and alternative hypothesis. So this is the one I described a while ago. This is the first step in hypothesis testing. We need to state the hypothesis. The hypotheses, as I said, are stated in such a way that they are mutually exclusive. That is, if one is true, the other must be false, and if the other is false, then vice versa. The next one is the formulating the analysis plan. The analysis plan describes how to use sample data to accept or reject the null hypothesis. It should specify the following elements. So this is related to p-value. Okay, the significance level. Okay, the significance level, often researchers choose significant levels equal to 0.01, 0.05, or 0.1. These are the most frequently used level of significance. 0.01, 0.05, and 0.10, which means that 0.01 we are assuming that we have a 99% confidence interval, while 0.95 we have the 95% confidence interval, and 0.10 is 90% confidence interval. But any value between 0 to 1 can be used. The next one, aside from significance level, is the test method. Typically, the test method involves a test statistic and a sampling distribution. Computed from sample data, the test statistic might be a mean score, a proportion, a difference between means, a difference between proportions, a z-scores, t-score, a chi-squared test, and so many other statistical tests. Given a test statistics and its sampling distribution, a researcher can assess probabilities associated with the test statistic. If the test statistic probability is less than the significance level, the null hypothesis is rejected. And then analyze the data. Using sample data, we need to perform computations called for the analysis plan. The test statistics is when the null hypothesis involves a mean or proportions. It is used either of the following equations to compute the test statistic. So for example, if the questions involve mean and proportion, these are the test statistics needed. Statistic minus parameter divide the standard deviation of the statistic. Or the statistic minus parameter equals to the standard error of statistics. When a parameter is the value appearing in the null hypothesis, and the statistic is the point estimate of the parameter. where a parameter is the value appearing in the null hypothesis and statistic is the point estimate of parameter. As part of the analysis, you may need to compute the standard deviation or standard error of the statistic. Previously, we presented the common formulas for the standard deviation and standard error. When the parameter in the null hypothesis involves categorical data, you may use chi-square statistics as the test statistics. Instruction for computing a chi-statistics are presented in the lesson on chi-square goodness of fit test. P-value is the probability value of observing a sample statistic as extreme as the statistic, assuming the null hypothesis is true. And then the last one is to interpret the result. If the sample findings are unlikely given the null hypothesis, the researcher rejects the null hypothesis. Typically, this involves comparing the p-value to the significance level and rejecting the null hypothesis when the p-value is less than the significance level. Now let's proceed to the statement of the problem. A statement of the problem is stated in a question form. It ends with a question mark. A question should begin with what, how, or which. This question should exhibit the effect of independent to the dependent variable. Example: how will the height of the ramp affect the distance the car will travel? Which amount of salt dissolved in water will freeze in the shortest period of time? How do the respondents exhibit their motivation in doing their current job? How do the school principals describe their leadership styles? What are the personal characteristics of the respondents? What are the factors that affect social responsibilities among the respondents? Which group of respondents has the best job performance? So this is how the statement of the problem should be done. Remember that a statement of the problem should end with a question mark. The source of the statement of the problem is the research title. The research title should contain all the information needed in the study. The research title and statement of the problem is identical in nature, such that a research title is a general statement of what the study is all about, while a statement of the problem is a specific questions based from the title of the research. Thus, title and statement of the problem are almost identical. However, it is stated in different way. A statement of the problem is a fragment or sets of questions. A problem starts from the most general questions, narrowing down to specific questions. Now there are elements of a research problem which needs to consider. The term research problem implies that an investigation, inquiry, or study is to be conducted, or that the problem is ready for an investigation. The first element of a research problem is that aim or purpose of the problem for investigation. This answers the question why. The subject matter or topic to be investigated. This answers the questions what. The place or locale where the research is to be conducted. This answers the question where. The period of time or the period or time during the data are to be gathered. This answers the question when. The population or universe from whom the data are to be collected. This answers the questions who or from whom. Now let's proceed to the characteristics of a good research problem. It must be researchable. It has theoretical significance. It has sources of information. It has a gap in the previous research. Now the statement of the problem and hypothesis. So these are the examples. of a statement of the problem and hypothesis. Number 1. What are the demographic characteristics of the research of the respondents in terms of the following? It may be age, gender, civil status, monthly family income, religious affiliation, and so many other demographic characteristics of a person. Number 2, how do the respondents assess the effectiveness of the bank's customer services in terms of? Okay. Number 3, what are the problems encountered by the bank employees in dealing with customers? Number 4, is there a significant difference in the assessment of the effectiveness of the bank's customer services when the respondents are grouped according to their profile? Is there a significant difference in the problems encountered by the respondents in dealing with the customers when they are grouped according to their profile? Is there a significant relationship between the effectiveness of the bank's customer services and the problems encountered by the employees? So that number 4 to 6 questions are a non-parametric or a parametric questions or an inferential questions. The number 4 is that we are asking if the assessment of male over female is different, if the assessment of those who graduated in college are the same with the assessments of those who did not take any college courses. The same with number 5 and number 6. Now the hypothesis. As you notice, the number 4, 5, and 6 are the same with the hypothesis. It's such that the word "is there a significant difference" was replaced by the word "there is no significant difference." There is no significant difference. There is no relationship. So these are the same. However, as you notice, statement of the problem is stated with a question mark at the end, while the hypothesis is also okay. It should be stated in a narrative form. Okay, it should be in narrative form. Okay, forgot the question mark. And it is stated in a null form. So from the beginning, these are the example of a research title, statement of the problem, and hypothesis. The research title would be The Study on the Effectiveness of Globe's Texters 5 Consumer Contest as Determinant of the Frequency of Purchase of Prepaid Cards by Selected PUP Students in the College of Engineering. Basis for Effective Marketing Strategy. And these are the problems. And this is the hypothesis. Again, thank you.